Okay, guys, so let's review what we did if you were absent yesterday or if you just want to review real quick for any sort of quiz. We went over velocity time graphs. First part, we introduced how to find the displacement. Oh, no, actually, displacement's tomorrow. We discussed how to find the acceleration by looking at the graph. So we're going to do that. I split this up into 5 different segments, and we're going to try that out. So let's practice reading the time intervals, all right? So segment A right here, happened between time intervals 0 to 5. So A happened between t equals 0 seconds to 5 seconds. So this is 0 to 5 seconds, all right? Cool. Okay. B occurred between 5 and 10 seconds. So the time interval for B would be between 5 seconds to 10 seconds, okay, and so forth. Okay, so that's what you kind of do. Just for practice, we'll do one of these longer ones. C occurred between time intervals t equals 10 to 25 seconds. Cool. Got it. All right. Then afterwards, we talked about the amount of change in velocity. All right. So we look at slope. We look at the slope of the velocity time graph. Slope, remember, is m. And in mathematics, we know that it is the rise over the run. Pretty self-explanatory. But if you look at what is the rise, what is the rise on this chart? It's the velocity. And by changing the y, you are changing velocity. Okay, so rise is actually a change in velocity. It's a change in velocity. Let me erase that. It's kind of nasty. So rise is a change in velocity. All right. Run is a change in your time. You're changing t. All right, change in t. So how do we calculate a change in? Right. Change in v is a v final, your final velocity, minus your initial velocity. Okay. And your time interval, or your change in time, is time final minus time initial. So let's do that for part A real quick. So let's see if we can calculate what the rise and run would be. So let's see. Our final happens at 5 seconds. So our final velocity is 20 meters per second. And we're going to subtract. Notice how I just kind of transferred that, right? I plug in 20 because it's my final. What was my initial? Also 20. Okay, good. Our time final was 5 seconds. And our time initial was 0, so we're going to subtract 0. Notice where I'm getting these numbers from, right? Just plug them into the right spots. Okay, so 20 minus 20 is 0, divided by 5. So our slope here, not surprising, is 0. But if you notice, what is change in v over change in t? Look up here, look at our equation. Change in v over change in t is acceleration. So guess what? This is our acceleration, measured in meters per second squared. That's meters per second squared. That's the unit that you need to put for all your acceleration values. Okay, so the slope of a velocity time graph is the acceleration. Let's do one that's a little bit harder. You notice here, if you have a flat line, the slope is 0. So D would also have a slope of 0, because look, it's a flat line, which means the acceleration is also 0, right? Okay, now let's do it for part B. Part B. Okay, so we want to do the same thing. We want to do the V final minus the V initial divided by the T final minus the T initial, right? Minus. Okay, so what's our V final for 5 to 10 seconds? Okay, so at 10 seconds, our V final is 5, right? So I'm going to put a 5 meters per second. Remember, that's the unit for velocity. Minus 20. Minus 20 meters per second. Good. Now we're going to divide by our time interval. Just subtract. Look what I did with my numbers, right? These match. Okay, time final. Is it 5 or 10? Well, 10 happened last, so 10 seconds. Minus 5 seconds. 5 seconds. So it comes over. Notice that. You don't have to draw these lines. I'm just showing you so that you can see where my numbers are coming from. Okay, so 5 minus 20, put that in your calculator. I would, just in case you're not comfortable with these numbers. It's 15 meters per second, negative. And we're dividing by 10 minus 5, positive 5 seconds. Look what's going to happen here. This ends up multiplying, you end up getting, it doesn't matter, it's acceleration. So negative 15 divided by 5 is negative 3 meters per second squared. But this right here would be the fraction comes up and flips, and you end up getting meters per second squared. So that's what would happen there. Okay. All right. Cool. So you got to do the rise over the run. So look here. So what did I do for segment B? I went, change my colored pen real quick. You can see a little bit better. Okay, look here. So I went 5, 10, 15, but this is negative 15, right? And then I went over. 5 to 10, this is 5. So what's the slope? Negative 15 over 5, right? This gets you negative 3 meters per second squared. Cool? Okay, we'll do it for the other one. This is kind of a fast shortcut. Okay? So over here, for C, I go up 5, 10, positive, right? Because I went up. And then how many over did I go? 1. Or let's see, 5, 10, 15. So 15 seconds. So over here I get 10 divided by 15. So this is, what is that? 0.6 repeating. Or you can do 2/3, right? 2/3. And of course the unit is still meters per second squared. And over here I shouldn't be doing any work because look at this. There's no rise. No rise whatsoever. There's just a run. Okay. All right. Good job.